Hello and welcome to this Wednesday afternoon. I had to check the calendar for a moment there. Iteration of my live weather and climate office hours. Just wanted to acknowledge, as I always do these days, that I'm grateful for the support of Climate Tech Reask, a company that is thinking about how to help organizations manage exposure to current and future extreme weather risk through predictive, dynamic, and physics-based modeling. Thank you again for your sponsorship of the channel. So today, what I really wanted to focus on was the unfolding heat wave across the west coast of the United States. This heat wave will probably have its greatest impacts in the highly populated coastal zones, or that is to say the inland valleys just inland of the coast in Southern California, as well as well to the north up in north central Oregon in the Willamette Valley, the Portland metro region, also experiencing notably and even potentially record-breakingly hot conditions later this week into this coming weekend. So I want to talk about that heat wave, which will affect all of the West Coast to a certain extent and all of California to a certain extent, although some places to a greater degree than others. This will not be an exceptional heat event in the San Francisco Bay Area in most places, although it certainly is hot away from the immediate beach. And also looking ahead to what this means for the rest of fire season in California and beyond. Not just the coastal parts of the state, but also places in the west that traditionally do see a ratcheting down of fire conditions at some point between September and November. And also maybe offer a few thoughts about the season to come and how that outlook has changed or not since the last time I discussed it. So as I mentioned, there is a big heat event unfolding across California and the West Coast right now, and it has not yet reached its peak. The peak will probably be Thursday or Friday in Southern California, and perhaps a little bit later still into the weekend across Oregon and interior of Washington, as well as the Northern Rockies. There will be sort of essentially two different zones that probably see most anomalously hot temperatures where they could be locally record-breaking. Not expecting to break too many monthly or definitely not any all-time records with this heat wave, which is quite different from the record-shattering event in July where we did just that. So not expecting that, but there probably will be some daily record highs. Some locations could get close to their September monthly maxima, not everywhere, but in a few spots, particularly in the inland valleys of Southern California, and also, as I mentioned, up in north central Oregon. And also, perhaps of more note, and a story that's been getting some attention in the past couple of weeks, is that overnight minimum temperatures will in fact be record-breaking across a much wider region, including much of California with this event. So we will see some of the warmest nights on record for early September across a pretty wide swath of California. May not sound as dramatic as seeing the hottest days on record or the hottest afternoon peak temperatures, but those nighttime temperatures are quite consequential from a health impact perspective. So from a human health impact perspective, an ecosystem health impact perspective, and also from a wildfire perspective. And that's the other thing I wanted to talk about this week, which is that California in the second half of August saw quite a reprieve for the most part in the wildfire world, with rain, even rare August rain along the north coast, and patchier showers even farther south, as far south as about the San Francisco Bay Area and the Tahoe area. Not everyone that far south got significant precipitation, but the north coast saw several inches, and some places up by Mount Shasta and Redding also saw an inch or two, and that really put a damper on what was up until that point, a rapidly accelerating fire season. Since then, it has essentially been dry and warmer, so we've lost some of the benefit of that moisture, although along the north coast that benefit remains, and quite frankly will probably remain for the rest of the season, along in some other pockets of interior valleys that got heavier showers from those earlier events in August. But the rain up in Oregon has not been enough to prevent a resurgence of wildfire activity. In fact, currently in Central Oregon, wildfires are very active. In fact, there are quite a few new ones that burned 5 to 10,000 acres each in a very short period. So right back to very active or even extreme wildfire conditions up in Oregon. In other parts of the interior West, including and especially focused on north central Idaho, western Montana, and western Wyoming, the very active wildfire conditions have never abated. So during this relatively wet and cool period along the coast of the far northern California, up along the north coast and into the Pacific Northwest, the interior West remained quite hot and dry, and there were multiple episodes of dry lightning. So thunderstorms with little or no rainfall, and as you might expect under dry conditions, those can spark a lot of wildfires, and so they did in the dozens or even hundreds of fires in this region, many of which are still burning because it has not gotten cool and damp there yet. Just yesterday, in fact, was a pretty big blow-up of wildfires in central eastern Oregon and Idaho, which resulted in a cluster of very large pyrocumulonimbus clouds, so fire thunderstorm-like clouds, some of which did produce their own lightning, but more interestingly, from a regional weather perspective, produced a significant injection of wildfire smoke very high into the atmosphere, up into the upper troposphere and lower stratosphere, the results of which were a pronounced swirl of smoke within a low pressure system. I have an animation of that I can show you in a little bit when I bring up the graphics for this conversation. But just wanted to emphasize that wildfire season is far from over. In fact, in places like Idaho and Montana, the wildfire season is currently at its more active than it's been at any prior point in the season. California, too, has been getting more active again in recent days after that August reprieve. The coffee pot fire in the southern Sierra Nevada has been burning for a while and has been burning more actively as of late. Burning in mixed terrain, mixed vegetation, and with mixed intensity, so perhaps some ecological benefits from that fire. Another newer fire, the Bear Fire, up north of Tahoe, not too far from Truckee, although not immediately threatening the town, started, I believe it was either yesterday or the day before, and has now burned several thousand acres, so that's a pretty significant fire, putting up a large smoke plume. Been burning actively for the past few days under dry and windy conditions. And then a new fire, I believe it's a 10 or 15,000 acre fire, I don't recall the name of it at the moment, on the southwest side of the San Joaquin Valley, on the eastern slopes of the coastal mountains. That one putting up a lot of smoke as well. So other smaller fires in Southern California as well, and I would expect that level of fire activity in California to continue to increase in the coming days with this major heat event that will be largely statewide into the weekend before fading. I would expect Southern California fire activity to really pick up under these conditions. It's favorable for what are known as plume-dominated fire conditions, so fires that generate large, tall convection columns atop the most intensely burning regions, and therefore can produce their own wind patterns that are different from the large-scale ambient winds with downdrafts and indrafts and all sorts of more dynamic fire behavior. So that may be a factor in anything that pops up in the next few days going into the weekend. The one good thing with this event is there's no strong offshore flow, so there's no very strong large-scale winds combined with the heat. That would always be a particularly dangerous combination from a wildfire perspective, and we don't really have that pattern in place. We don't have that strong pressure gradient that you need to generate those strong offshore winds with this event. So we do have some weak offshore flow. The winds are blowing from land to sea. That's one of the reasons why even the beaches will be warmer than average, although not extremely hot. And it's also one of the reasons why places like the San Fernando Valley and the Inland Empire in Southern California will be extremely hot on Thursday and Friday this week. In fact, temperatures potentially approaching within a few degrees of all-time records. Now, the all-time record and the monthly record and even some of the daily records are about all the same, because this is the time of year when some of the very hottest temperatures on record have occurred in recent years. Most recently in 2020. This heat event probably won't be quite as extreme as the September 2020 event, which was record-breaking, set new all-time temperature records across a broad swath of the inland valleys of Southern California, in particular in the San Fernando Valley. But it could come pretty close. Recent model indications are that this will be within a degree or two of that event. So that is something that prior to 2020 would have been all-time record-breaking. So still, in the scheme of things, quite a remarkable heat event, potentially in some parts of Southern California. Does not look like the offshore flow during this event will be as intense. Well, not that it was intense, but it won't be quite as strong as it was back in 2020. That will probably reduce the amount of compressional adiabatic heating in places like the San Fernando Valley by a couple of degrees relative to 2020, and also means the record-breaking heat probably won't extend as close to the coast. So the immediate beach, if you're in Santa Monica, for example, probably not going to see record-breaking temperatures with this one, although it will be arguably a good beach day, quite warm with some weak offshore flow, or at least a lack of onshore flow, and sunny, fog-free conditions. So some pretty extreme heat in the Inland Empire, San Fernando Valley, these kinds of places, potentially getting within a few degrees of all-time records in a few spots. So that is a notable heat event. It will almost certainly be the hottest day of the year in a lot of Southern California, and perhaps even the hottest day in several years in some parts of Southern California. So again, this is a significant heat event. It will also be the most significant heat event subsequent to the 2 consecutive wet winters and good grass and brush vegetation growth. So we do have that combination of a heavy grass and grass crop across Southern California from the antecedent 2 winters that I've been talking about recently, those beneficial growing conditions, a little extra growth of the brush, the chaparral, that has probably added some biomass over the past 2 years in these wet conditions. So as things do dry out, there is a significantly elevated fire risk, not wind-driven fire risk so much in this case, but just fuel and aridity-driven. So this is sort of why we would be most likely to see plume-dominated fires. The atmosphere is a little bit unstable. With these hot conditions, there's a lot of additional grass and brush growth this year, so we haven't seen those kinds of fires so much this year in Southern California. Not too surprising, because the fire season in coastal Southern California usually does peak later than elsewhere in the state in most years. That can continue well into autumn and even into early winter if the rains don't arrive early, and there's a pretty good chance that happens this year. In fact, the official predictions from the Federal Predictive Services are just that the fire season for the rest of the season, meaning from September through December in coastal Southern California, will be more active than usual, and that is in many years often the peak of the season to begin with. So that could be quite an active period to come, and this heat wave may well kickstart it, because even though this event isn't coming with strong offshore winds, there almost certainly will be stronger offshore winds at some point in the next couple of months, and events like this tend to dry out that vegetation leading up to those events. So again, unless we get a widespread soaking rainfall at some point between now and the first offshore wind event, the accumulated fuel drying from this heat wave in Southern California will contribute to that fire risk weeks or even months down the road. Up in Northern California, as I mentioned, it's going to be hot the next few days. It has been hot the last couple of days, although not as extreme. Probably not many, if any, daytime record high temperatures, although there may still be record warm overnight temperatures across a wide swath of Northern California. And then as we go north into Central Oregon, the Willamette Valley, Portland, etc., could see multiple days above 100 degrees. And once you get as far north as Portland, September is pretty late to be seeing multiple consecutive 100-degree days, so the city itself, in fact, might tie or even break the record for the latest 100-degree day in the calendar year, as well as the record for the cumulative numbers of days over 100 degrees. That's fairly remarkable, given that August was actually cooler than average and featured multiple rain events that were highly unusual. We still managed to see, or will manage by the end of this week, to see a record-breaking number of 100-degree days up in that part of the world this year. So that's a bit of a striking statistic in and of itself. The same thing is true of California. I don't believe the official NOAA statistics are out yet in terms of the August numbers, but it's pretty clear that summer 2024, so it's speaking June through August of this year, will turn out to have been the hottest summer on record for most of the Southwest, and this does include most of the land area of California. Although, as I've noted previously, it does not include the densely populated coastal strip, where this summer was, in fact, fairly close to the middle of the pack, temperature-wise. So at least up to the present, this may shift a bit with this upcoming heat wave on the warm side, but up through the end of August, most parts of coastal California did not see an exceptionally hot summer. I think that comports with a lot of folks' personal experience. So we've seen yet another year where the vast majority of the land area of the state, and indeed the vast majority of the Southwest, including the Southwest's other major interior population centers, so places like Las Vegas, Phoenix, and Reno, did in fact experience record-breaking heat this summer, but Los Angeles, San Diego, San Francisco did not. And so an interesting divide between the coastal, those who experienced the natural air conditioning of the Pacific Ocean this summer, and those inland that decidedly did not. And the other interesting piece here is that even in Northern California, the month of August itself the whole month was not particularly warm. It was relatively close to average temperature-wise and even significantly cooler than average along the north coast where aseasonal August rain fell. It was somewhat warmer than average in Southern California, but not remarkably so. So the fact that summer, which again includes the 3-month period between June and the end of August, still managed to be the record warmest period on record for a good portion of the state, despite the fact that some of the same portions of the state saw an average or even slightly cooler than average August, is actually kind of incredible and speaks to just how insanely hot it was in June and in particular in July. July just shattered so many temperature records in California. I think it's still a little bit difficult to account for all of them. So it has been a dynamic summer. It hasn't been hot the whole summer, and it hasn't been super hot everywhere. In fact, some places saw a pretty ho-hum summer by most definitions, and yet your mileage varies greatly. And there are some parts of California that if you take a 20 or 30 mile transect from the Pacific Ocean coast to the inland valleys, you would go from seeing a summer that saw temperatures near average for the 20th century, so remarkably unremarkable, and put another way, to at the other side of that 20 or 30 mile transect going inland, a place that literally experienced its hottest summer in over a century of record keeping. So that is a pretty remarkable contrast. And some folks have said, well, yes, obviously the coast is cooler than the inland valleys in California in summer. That's an obvious reality. And of course, that's true that almost always California's coastal zones in summer are significantly cooler than inland areas because of the moderating influence of the relatively chilly Pacific Ocean, along with the isolating effect of the coastal mountains that keep that rain influence relatively close to the coast. But what I'm saying is that contrast between relatively average temperatures near much of the coastal zone and literally record-breaking temperatures, not very far inland, is an even greater contrast, probably the greatest contrast that we've ever seen between the coast and inland for any historical summer period. I don't have the official math done on that, but I suspect that it would probably be true that this summer featured among, if not the greatest contrast between coastal temperatures and inland temperatures. And that is a pattern we've seen a lot of in recent years where the coast has experienced a relatively mild summer, sometimes followed by a very warm autumn, which so far is what has happened in the first week of the season, at least. But that inland areas experience just this sequence of concatenated record heat events back to back to back to back. And there is a bit of an open question the degree to which that remains the case in a warming climate. It's clear that inland areas will warm more than the coast in general, just by virtue of that background temperature gradient. But what will happen to California's coastal marine layer, I think, is a little bit uncertain. I think there's a lot of folks who might assume one or the other thing, and I've heard two very different camps of people whose intuition leads them in different directions. One camp is, well, clearly we'll see less fog in a warming climate. Clearly there'll be less fog and the coast will warm up more. Other folks say, no, clearly we'll see more fog in a warming climate because we know that the sea breeze circulation that draws that cool, moist marine air inland is partly driven by the temperature differential itself. So the stronger the difference between the hot Central Valley, for example, and the cool temperatures along the beaches of San Francisco, the stronger that marine, that sea breeze, that delta breeze is going to become, and sort of have this mitigating feedback, where the more inland warming there is, the stronger the sea breeze you get, and the more moderate the coast stays. And the interesting answer scientifically is that at this point we don't really know. Those are both valid mechanisms, and they could both actually be true under different conditions, and this answer is largely unknown in California. It may be a different answer in Southern California versus Northern California. We have that really cold water upwelling off the northern and central California coast, that California cold current. Just imagine how cold that water is near the Farallon Islands west of San Francisco, compared to how warm the water is, say, near the Channel Islands west of Los Angeles. The water there is still cool for its latitude, but really just dramatically warmer compared to Northern California. So not at all uncommon to see 50-degree Fahrenheit water temperatures near the Farallon Islands in summer, and also not uncommon to see 70 to 75-degree water temperatures some years in the Southern California Bight, that region south and east of where the coastline bends eastward along the central coast of Santa Barbara and Ventura counties. So there may be a different answer in Southern California and Northern California. And there may be a different answer in summer when the marine layer is strongest versus autumn. My personal gut instinct, and this is sort of me as a California climate scientist and meteorologist reading between the lines a bit, I actually do tend to think that there may be both a seasonal and a geographic gap. So my hypothesis, which is largely unsupported by any specific research, but is piecemeal supported by a few disparate pieces of anecdotes and evidence, is that I do think we will probably see a reduction in the marine layer inland penetration and the moisture associated with it in most years in Southern California, but this will manifest more strongly in late summer and fall. Contrarily, up in Central and Northern California, I tend to think that this enhanced sea breeze mechanism, at least from about May through July, may win out. And places like San Francisco and the coastal Bay Area and the North Coast may continue to see a very high prevalence of summertime fog as the Sacramento Valley heats up dramatically and that thermal circulation strengthens. But I think that in autumn is where this relationship breaks down in both Northern and Southern California, because we tend not to have as strong of a marine layer. That time of year, the ocean is not as cold. There's less onshore pressure. There's less of a pressure gradient to drive those onshore winds in autumn to begin with. And that's where I think we might see more equal opportunity, at least in a spatial sense, if you will, warming compared to the summer. And one piece of anecdata that fits into that hypothesis is the fact that we have been seeing relatively mild temperatures along the immediate coast some of these summers that have been record-breaking inland, but then we go on to see record-shattering heat along the immediate coast in September or October. So keep in mind that places like San Francisco and Santa Barbara and San Luis Obispo, LA County west of the mountains, all of these places have set new all-time record high temperatures in the past 5 or 10 years, but it hasn't happened for the most part in summer. It has happened in fall. And this partly, again, has to do with that background seasonality that California coast usually experiences its hottest days of the year in autumn. But I also have to wonder if this has to do with the fact that sea breeze mechanism, that mitigating feedback, isn't allowing the coast to get so extremely hot in summer, and that might actually be accentuated in a warming climate. But in fall, that protective mechanism doesn't exist to the same extent, and that may be explaining what we're seeing. So this is pretty much just me voicing a scientific hypothesis live on YouTube, because surprisingly, there's not a great deal of research on this. There have been a few studies that examine each of these mechanisms in isolation, and if you only study the sea breeze mechanism, it looks like the coast stays cool. If you only study the air mass drying mechanism, it looks like we see a lot less fog. But no one has studied this all at once, and it turns out that the answer is quite sensitive to the model you use, and the answer is likely different, summer versus autumn, and northern versus southern California. So just to say, even when it comes to something that seems like it should be fairly simple, like coastal fog and the marine layer in California, there's still a lot of details that need to be worked out to the point where I actually can't give a clear answer. But that's the most comprehensive answer I think I've given to date, and it would be an interesting research hypothesis, but it would require actually some pretty heavy-duty numerical modeling with weather models that can resolve California's complex coastal topography and the strong ocean-atmosphere coupling that we get that drive these sea breezes and these autumn heat waves. So, a bit of a tangent, but I figured folks would find that interesting today. Given the prevalence or the occurrence of extreme heat wave in some parts of Southern California this week. All right, so I think that's the overview for now. As always, at the end of the session, I'm going to be taking another look at the chat for questions that I can answer. So consider formulating your questions now regarding this unfolding heat wave in California and fire season. Those would be the two main topics for the discussion today. But in the meantime, I'm going to, as I have started to do regularly, share my screen so folks can see some of the interesting visuals that have popped up in recent days. Bear with me for a moment. You'll see my screen briefly. You'll see my messy desktop today, since as I switch over. Just need to make sure I actually do it. Okay, so you're seeing the infinite mirror. I know it's irritating, but it is actually a good thing, because it means now what you're seeing is a live satellite image of the western US. And I still think it's an incredibly cool reality. For all of the concerns we have about technological progress, I do think it's kind of amazing that I'm speaking to a fairly large audience of folks live on a website currently, where I'm piping live satellite data that's about 5 minutes old from the Goes West satellite provided by the US government, taxpayer funded as always, looking down on the western US. So this imagery is beamed down from space about 5 minutes ago, straight to your eyeballs. Anyway, and some interesting meteorological features on the map today. I'm going to bring up my screen drawing tool so to highlight a few of them. One of which is you can see this low pressure zone over, I guess it's centered over Wyoming now. So you're seeing that cyclonic spin. So all these clouds, this cluster of clouds you're seeing here, these are all thunderstorms spinning around the low over Wyoming. But you can kind of tell there's this axis, this vague axis sort of smoke of that hazy air here. This is all residual smoke from the wildfires in Idaho that blew up yesterday. It looks like they're a little bit quieter today right now, but I'm guessing in the next few hours these fires will blow up again, because there's quite a few of them. But check out Oregon. I mentioned that Oregon fire season had leapt back to life once again, and you can see there's a lot of fires burning right now in Central Oregon. I'll zoom in on that in a moment, but you can see generally that there is quite a lot of smoke being produced in this region. Not as much smoke right now from fires in California. Let me quickly get rid of the screen drawing tool. I was going to double check the name of that fire. I think it's the Boone Fire. I believe that's correct. So I'm going to zoom in first on California. So looking at currently what's going on, a lot of clear skies, so not a great deal of activity. There is, as you can tell pretty clearly, a nice marine layer right along the coast of Central California. So this is off the coast of the Bay Area. classic marine stratocumulus deck there, keeping the immediate beaches cool. But it is hot inland, so San Francisco, not so hot today. But all you got to do is go inland of the East Bay Hills, and it's pretty hot to the east of that line. But the other thing we see, this is, I believe, the Boone fire. So you can see it burning, the smoke plume, as I mentioned, on the west side of the San Joaquin Valley in the Coast Ranges there. You can also see, if you squint a little bit, this is the coffee pot fire in the southern Sierra Nevada. Not burning so intensely right now as it was in recent days, but I suspect it'll pop up more as temperatures rise over the next couple of days. A little bit easier to see these fires if we go to the infrared imagery. And again, there's that black dot right there that you can see. And I almost wouldn't be able to tell the coffee pot fire if I didn't know where it is, but there's a little bit of a heat signature there. The other fire of note right now in California is the Bear Fire, and I'm just going to see if I can zoom in. Yep, again, looking not so intense today, but there is a little bit of a heat signature, as I mentioned. There it is. So, as I mentioned, you're well north of Tahoe, also somewhat north of Truckee. Certainly no immediate threat there. And if I go up into Oregon, just to show the scope of the fire activity up there, you can see that there's actually quite a lot. So I'm going to keep this on. So fire there, very large fire here, 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 etc., etc. Along with, you can see these other fires percolating in central Idaho. So this is really where the bulk of fire activity is in the western U.S. at the moment, but I'm expecting that across California, conditions will really pick up in the coming days. Just trying to see if there's anything. There's been a few persistent fires up in, whoops, I don't want these to stay on the screen, so I need to get rid of these. There we go. Also a couple fires down in the Basin Range region down into Nevada. And just to show folks, I want to just, this is an animation, again, this is from yesterday, from Colorado State University, the Sierra Institute. But I just thought it was really kind of cool. This is that gigantic smoke-filled vortex over Idaho yesterday after all of those wildfires injected smoke all the way into the upper troposphere and lower stratosphere over Oregon. Again, these are those, you can kind of see where some of the smoke was originating from here in Oregon. But this is that swirl that I mentioned is now over Wyoming. Has a little bit less smoke in it now, but this was the pretty dramatic smoke front. Look how sharp the edge on the smoke front is. So if you were in the middle of the far northern Nevada desert, anybody going east from Burning Man, I guess. Not a lot of roads there, but who knows. Or if you were in the Sawtooth Mountains or somewhere else in the Snake River Plain in Idaho, this would have been a pretty cool view to your west to see this coming through. And it's a nice illustration of what happens when you put a passive tracer in the atmosphere. So this is directly visualizing atmospheric flow right at the top of the troposphere, which is hard to do because we often don't get a lot of clouds up there. But if you have fires that are intense enough to inject that smoke up there, this can be the result. And you can even tell if there's smoke at different levels of the atmosphere. Right around here you can see smoke that's at a lower elevation where the cursor is flowing east, but you can tell that this is at a much higher elevation as well. So I thought that was kind of cool. One thing I wanted to note, this is a nice little tool showing places where record temperatures are predicted in the coming days, officially by the Weather Service. So I just want to show you what that looks like. Maybe a record temperature or close to it today down by the Mexican border in the Imperial Valley. But the main record-breaking heat is not, well, I guess what this really goes to show is that at least officially, not a lot of locations in Southern California are predicted to break record high temperatures this week. So you're not seeing a lot on the map here, maybe a couple of places between here and Sunday. But take a look what happens when I look at record overnight temperatures. Look at all these locations now. All of a sudden, we see lots of places that stay in the 70s and even 80s overnight. So Thursday night, Friday night, Saturday night, and into Sunday night. And those will be record-breaking overnight temperatures. This includes everywhere from the beaches of LA County to the Inland Empire to the high and low deserts, and even extends over to places like Phoenix and over towards Las Vegas. So I think that we're likely to see a lot more record-breaking overnight warmth in Southern California than record-breaking daytime warmth, although there is a chance that a couple of places could get close. And I think that there's a possibility that the San Fernando Valley sees higher temperatures than are currently officially in the forecast, and that would cause additional records to be broken. Now, if I go up into Oregon and Washington and look at this region that's currently experiencing a lot of wildfires, we actually do see a lot of record-breaking temperatures. So you see the record-breaking 105 degrees in Medford, Oregon on September 5th, and up in Portland, Salem region, 102 to 105 zone. Another 100-degree day on Friday, which may set the record for the latest 100-degree day on record up there. And even some places as we get into eastern Washington into the weekend, going into Idaho. So these very hot temperatures, again, keep in mind where these fires are burning, likely to see a pretty big uptick in wildfires. Not so much from the Cascades westward, but especially east of the Cascades into next week, with some record-breaking overnight temperatures up in this region as well. So the last visual that I wanted to show before I'll take it back to the Q&A is the following. So as often, as is usually my preference, let's see if the model update cycle is done. It is done, so we can use this one now. This is the European model ensemble geopotential height anomaly map. In other words, a measure of the relative unusualness of middle atmospheric pressures. So the redder and the more orange it is, the more anomalous. These are in units of standard deviations. So we can see going back in time, this was that weak low pressure system we had over the weekend that drove some breezy and cooler conditions across Northern California, but didn't really bring anything other than a couple of sprinkles. And now we go to the present. We see that this strong ridge has built over California, and we can also see that it's starting to build more strongly over Southern California, and then again up in the Pacific Northwest, which is consistent with those two regions of maximally anomalous temperatures expected during this heat event. And as you see, today is not the peak of the event. As we go into Thursday and Friday, this ridge strengthens over Central and Southern California, and this is why Thursday and Friday are likely to be the hottest days of this significant heat event in Southern California. As you can see, as we get into Saturday and Sunday, the ridge weakens a bit, but persists inland. So a bit of an inland shift as another very weak low moves into Northern California. Again, not enough to produce any precipitation, maybe an isolated thunderstorm over the Sierra Nevada, but nothing otherwise of note, but cooler and breezier conditions likely by the weekend. And then look what happens as we head into the middle of next week. Fairly hot conditions redevelop over Southern California, but continue to fade across the Pacific Northwest and Northern California. And as we get out about a week from now, there is a signal for a pretty breezy southwesterly flow pattern. This would bring somewhat below average conditions to Northern California, but continued above average temperatures to Central and Southern California. But what's really notable is that this will result in stronger mountain winds and stronger winds across eastern Washington, Oregon, and Idaho, as well as the Great Basin. This has the looks of a significant fire weather threat following the heat wave, and given how much active fire is already on the ground up in certain parts of Idaho and Oregon, but also parts of interior Northern California and Nevada. So that's going to be something to look out for. Again, this is not an offshore wind pattern, but rather an onshore wind pattern with winds from the west to east. And as we head, this is closer into the middle of September, we see that this troughing signal is still present, but weakens as it moves inland, potentially as a renewed ridging, although not as strong as we saw earlier in September, builds across Central and Southern California. So on average, on balance, this would be a pattern that would favor slightly above average temperatures continuing, but there is a wider range of outcomes in the broader ensemble during this period, and this is sort of what I want to emphasize here for the next week. So this is 24-hour moving windows of potential precipitation. You're seeing occasional spurts of coastal drizzle. This is just from the rain layer, so you can kind of ignore it. A little bit of precipitation painted over the southern Sierra Nevada. That may be in the form of isolated thunderstorms as we go into the weekend. But otherwise, things stay quite dry. We see a little bit of precipitation up over Idaho, but I think this will probably hurt more than help the fire situation, since this is likely in the form of thunderstorms with little or no precipitation as we get into early next week. And then conditions dry out again as we head about a week from now. That trough I mentioned probably will bring some showers to the Pacific Northwest, western Washington, western Oregon, and probably also the far north coast of California. So the northwesternmost couple of counties in California, as have seen recent events in recent weeks, some precipitation with a slight chance of some showers about 7 to 10 days from now, extending up to around Mount Shasta. But not a lot of indication of precipitation even as far south as saw it last week. So I would be more surprised if anyone from Mendocino County southward saw more than a brief sprinkle from this pattern, at least as it currently appears. And then there's a pretty strong dry signal reemerging by mid-September. There are some hints in a couple of ensemble members from the model. As you can see, this sort of has a little bit of precipitation in the ensemble average overspread Southern California. But there could be a brief late monsoonal or tropical moisture surge into the southeastern California deserts at some point as we get towards mid-September. Wouldn't be that unusual to see that this time of year. Currently, there's only a slight chance that happens, but it's something to keep an eye on, as well as a very slight chance that an early season trough brings some isolated showers to Northern California at some point. But overall, this is a pretty dry pattern across 80 to 85% of California. And if we just show the accumulated ensemble average precipitation, the net result is not too impressive, except again, Del Norte County, far northwestern California, might see some decent showers over the next couple weeks, but pretty much everyone else stays in the negligible to zero territory, at least as it currently looks, without any season-ending rainfall still in eastern Oregon or most of Idaho where the fires are burning. So I think fire season is likely to kick into higher gear once again with this pattern. All right, so I'm going to stop sharing my screen, bring back the questions here. All right, just give me a brief moment to take a sip of water. Yeah, there's a couple of questions and comments. It is, as strange as it still feels to say, it is very helpful when folks like these videos, share them, and subscribe to the channel. Those are the metrics that the algorithm is using to determine how much to spread this information around and to grow the channel. That's what we got to do. So thank you for that kind of support. We are trying to get to 10,000 subscribers by the end of the year. I still think is a very reasonable goal, but we still got to get about 1,800 people to sign up. So if you haven't done that yet, now would be a great opportunity to do so. Okay, I'm going to take a look at questions. We don't have too many today, so right now it looks like I can get to what is here. Not too many questions at all. So again, this is your opportunity for the interactive portion. So let me go down and see what we've got here. The first one, Connor asks, thank you for the kind words about the blog. If you had to recommend one book on your shelf, what would it be? Right now, or one of the ones that I thought was really quite excellent, and it has won a number of awards, so apparently I'm not the only one to think this, is Fire Weather by John Valiant, and it's really motivated by Canadian wildfires, in particular one specific wildfire, the Fort McMurray fire, back, I believe it was in 2016, that devastated essentially this oil extraction community up in the tar sands of remote northern Alberta. And it was a place that now many places in California have had similar or even worse experiences with wildfire completely enveloping populated zones. But there are some unique things about the Fort McMurray story that make it particularly poignant, partly because, again, We know that climate change is worsening wildfire burning conditions in most places where wildfires occur globally, including the boreal forests of Western Canada and, of course, California too. But the other interesting piece is and even as a climate and weather scientist who works a lot with fire scientists and studies wildfires specifically, I still found a lot of what's in this book to be interesting and also largely accurate. So I tend not to recommend things that do a very bad job of presenting the science, but presented it in a way that I think is really interesting for a broad audience and ties together some loose threads that I don't think I had previously thought about. So I definitely recommend Fire Weather. I think it's something that folks who have recent wildfire-related traumas in California might want to think twice about taking a deep dive into, at least until you're sure that you're ready. But it is an experience that is now increasingly shared across countries and continents. There are places in the Mediterranean, in South America, especially in Chile, in Australia, particularly southeastern Australia, where there have been these kind of similar experiences with wildfires having been part of the landscape, part of the ecosystem, part of the natural environment for millennia, or really for as long as there's been combustible vegetation on planet Earth, but suddenly feeling like they're a lot more prominent in the public eye and in the public consciousness, partly because our relationship with fire has changed in what Stephen Pine has called the Pyrocene, this era that is really increasingly dominated by various types of fire, both purposeful and cultivated and otherwise. And also that the character of those fires is changing. It's not just that our relationship with fire, wildfire and otherwise has shifted, but it's also that we truly are seeing conditions that we have not seen previously, as we modify the landscapes that these fires burn in and as the climate warms. And these things are always multifactorial, but I thought it was a really interesting way to tie all of this together. And I say that as somebody who works in this space pretty directly. So I think I answered Mary's question about fog, which is to say I gave a non-answer to say we don't know, and sort of explained why there are two countervailing hypotheses, each of which might still be correct but operating in different places at different times. All right, let's see. Oh, thank you, Mark, for the feedback on the discussion earlier today. I've been doing a lot of live streams. And after this, it's on to the next one. See me on ABC 7 News. There was a conversation we had this morning on hydroclimate whiplash in California and the potential role that nature-based interventions could play in ameliorating some of those impacts. And this was an event that was hosted by the organization Sustainable Conservation. It's part of the kickoff of their webinar called Recharging California. And if you missed it, they're actually going to post the entirety of the conversation that we had earlier today. It's about an hour long on YouTube, and I will share that via the channel once that's up. So another good reason to subscribe to the channel is that you'll also be notified when I have other tidbits like that aren't directly related to these live streams, although you should also be notified when those are either scheduled or when they begin, depending on how you set up your preferences. All right, well, it's a relatively quiet question day today, perhaps because, at least as far as what's going on outside the windows today, maybe not so dramatic. Possible that more folks will have questions in a few days. once the peak of the heat arrives in Southern California. As I mentioned, I've been busy today, and in terms of the video and audio content, you'll be able to see these other things on the web, and I think that's about all I've got for the moment. But thank you as always for joining, and I will plan to schedule another session certainly next week, and you never know. Those who follow consistently know that I will occasionally do pop-up sessions in between scheduled ones as conditions warrant. If the heat ends up being particularly extreme in Southern California, or if we really do see a major spurt of new wildfire activity, I will consider a pop-up session in the next couple of days. So stay tuned for that. But otherwise, thanks for joining, and see you next time.